Alright, everything we do here at Far From Standard is that we want to make relationships to previously known material. Okay? And oftentimes students who get into physics too think things are so much more different because we're dealing with electricity and charges and things that we don't actually ever see. Okay? I want to show you that the material is very similar between first semester and second semester physics, and so if you start thinking about it in terms of these similarities, it may help you connect the dots. Okay? And one of the main connections that I wanted to make is regarding gravitational fields and electric fields. Okay? Now gravitational fields are produced by any object that has mass. Okay? So anything that has mass associated with it is going to cause a field, which is a disturbance in space around it. Okay? So here I have the Earth drawn as this blue ball, and there are 4 black vectors around it. Technically I could draw billions of vectors around it because in every direction there is going to be a gravitational field pointing in towards the Earth. Okay? But I wrote the equation out for the G field, what we call the gravitational field, which is capital G, which is the universal gravitational constant, times the mass of the Earth over the radius of the Earth squared. Okay? So at any point around Earth, you can find the magnitude of the gravitational field by just plugging it into this equation. Okay? And again, you can see that this equation has radius squared or distance squared on the bottom, and therefore this is called an inverse square law. Okay? Now let's flip over to the negative charge on the board here. Okay? Now I use a negative charge because with positive charges, electric field lines go away from them and they go in toward a negative charge. So the negative charge is more like a mass like the Earth. Okay? So in blue I have the electrical field vectors all pointed towards them. And again, I could draw millions of these blue vectors in all directions around this theoretical spherical object. Okay? And here I have the equation written for the electric field, and I put it next to the gravitational field by design here, because the equation is a constant, Coulomb's constant, K times Q over R squared. And so I really wanted to show you the similarities here. There are 2 constants, which are G and K, and then the equivalence to mass in the electrical world is charge, so that's M and Q. And then the r's on the bottom are the same as well. They're both squared. They are both inverse square laws. So just keep in mind that the electrical field equation is very similar to the gravitational field equation. They have different variables, different values are used, but it should be interesting for you that 2 of the most fundamental laws of nature have such a relationship in their mathematical formulas. I hope this helps clear things up. Okay? And stay tuned for the explanation on how this relates to forces.